So how much work does David do on the parachute? And again, just being cautious with the words in this question, just to make sure that we're answering it correctly, because we do in fact have forces acting on two items here. One is the parachute. So we have the parachute here, and it's getting pulled, and David's pulling on that, so adding a force to that parachute. Of course, David running this direction, he's getting pulled back. And we know that because if we cut the parachute off him, he could certainly run faster. And so the parachute is pulling back on him or doing work against his motion. So let's make sure that we're answering the question correctly. Are we talking about the work on David or the work on the parachute? How much work does David do on the parachute? Okay, so this is what we're looking at here. And so work equals force times distance. And the distance in this case, or the force in this case, is 150 newtons. And the distance, 20 meters for his sprints. And we'll make sure that's a positive when we're done because they're both happening in the same direction. In other words, for the parachute itself, and that's why we have to be clear, the parachute itself, it's getting pulled to the right by the way we drew it, and it's also moving to the right. So positive, an increase in energy. And so we can figure that out. So we have 3,000 joules. All right, so 3,000 joules, and we can mark it as a positive because we know that it's work that's adding energy to the system, to the parachute. And the question, is this work being converted into potential or kinetic energy? Well, because he's able to move it and he's getting faster as he pulls it, we definitely know that this is being converted into kinetic energy.